right? So we know that this distance over here is 30. And then we also know that this distance over here right? This is 40, right? So 30 squared plus by 40 squared, right? So when you square root them, so 30 squared plus by 40 squared, so it's equal to 50. So our radius of the circle or maximum shear stress is at 50. So from here, you can draw the Mohr circle, right? So 50 is the radius. So you have it over here, and then okay. So this is the Mohr circle, and this one, okay, I'm going to put over here. This belongs to your XY plane, okay, which is your in plane. Now, the next thing we know is we know that there's a point over here, right? This belongs to point Z. Okay, that belongs to point Z. So we can draw two more circles. Okay, so one circle that we can draw now is this circle over here. Okay, so between point Z and I'm going to label this stress A and stress B. Okay, so this is our stress A, and this is our stress B. Okay, so I will write down here stress A and B are the principal stresses, and this is because the shear stress is equal to 0. That's 0 shear stress at stress A and stress B. So from here, I can draw two more circles. Okay, so one circle is here. Right? Okay. Now, the next thing is which plane does this circle belongs to? Okay. Is it the XZ plane or YZ plane? We know Z is definitely one of the planes, okay? Because one of the points of this circle touches point Z, right? But how about point B, right? Is it belongs to X or Y? So the rule, okay, so if this angle, so I call this alpha angle, right? If alpha angle, right, is less than 90 degrees, which for this case is, okay, then the origin is point Y, right? So this is point Y, right? It's less than, alpha is less than 90 degrees. So therefore, over here, this belongs to our YZ plane, which is our out of plane. Now, it cannot be XZ plane because to go to point B or to the smaller circle, right, it has to rotate what? I'm going to call this angle beta. Right, beta over here, is it less than 90 degrees? The answer is no. So it cannot be XZ plane. It has to be what? YZ plane. Okay. Now we will have another circle to draw. Okay. And then we will discuss which plane it belongs to. Okay. So there's another circle over here. And the circle is this. Okay. So okay. So if you look at this circle now, it also touches point Z, right? But this angle over here, I'll call it gamma angle. Gamma angle is from point X, right? So this circle over here, which is the gamma angle is less than 90 degrees, so this belongs to your XZ plane. And this is also your RR plane. Okay. So it cannot be from point Y, right? Because if this angle coming to stress A, this angle I call it alpha, beta, gamma. My numerical or tau. Okay. That angle tau has been used. I call it angle I. Okay, angle I, right? So angle I is greater than 90 degrees, so it cannot be YZ plane. Okay, it has to be XZ plane. Are we clear? So this is how you identify. Lee, yes.
I don't get why the blue circle is YZ. Is it because the blue circle is closer to the Y point Y?
The blue circle is it's nothing to do with closer, it's more to do with the angle. Don't look at it as a closer distance, look at it as an angle. Okay.
Y alpha is less than 90 than the origin is Y.
Because you look at alpha, the way it's constructed is less than 90 degrees.
Yeah.
By inspection. Okay. I did not create this. Okay. It's the fact that point Y is at that orientation and to the principal stress, the angle over there is called alpha. I just call it alpha, Lee.
Yeah. But I don't get why the angle less than 90, then it will
So
be.
how can it be greater than 90? Oh, you don't know the reason behind why it is
Yeah.
less than 90. So when it's less than 90, so how the element rotate? Okay, so originally, this is our rotation. Right, this is our original. Right, so the XY plane will have to rotate the alpha angle. So rotate alpha angle, it rotate this way. Okay, so this has been rotated as alpha over 2. Right, element and Mohr circle. So the original one, you have shearing stress now. Right, so this is your original. Now with this orientation, you only have what? You only have normal stress. And over here, stress Z is still equal to 0. Okay, so if we look at our orientation now, right? So now we look at our YZ plane. Right now we look at a YZ plane. Right? You only have a tensile stress over here. And stress Z, so this is your stress B. Right? Because it's tensile. Z is equal to 0. So this over here is your what? YZ plane. So that's why this circle over here belongs to the YZ plane. Does that make sense to you now?
In the YZ plane, there's only a pencil.
Yes. Right, by looking at the YZ plane. So we make it look like 2D. Lee. So when we draw 2D Mohr circle, right? When we construct 2D Mohr circle, we only construct stresses in these two planes, yes or no? This surface and this surface. We don't care what is going on this surface, yes or no?
Yeah.
The same thing. So I know there's a stress going in this way, right? But we don't bother about it.
Yeah. Okay. Okay. Yeah. I got it.
Okay. So that's why that belongs to the YZ plane, and that's why that belongs to the XZ plane. Okay, it's the acute angle. Don't look at distance, look at acute angle, because distance sometimes can make you very confused. Okay. Okay. Now I'm going to do a problem. Okay. That before I do any problems, okay, I have some more to do on this example over here, which I'm going to show you how it is calculated. So now, if we are going to calculate the tau max, okay, tau max for the YZ plane, right? So YZ plane is equal to what? So if you look at stress B, right? Stress B is 30, yes or no, right? So tau max is for YZ plane is 30 divided by 2 is equal to 15 megapascal. Okay. And then if we were to calculate tau max for XZ plane, so this is, so you look at the minimum stress to 0. So this is minus 70. So tau max is always an absolute value. It's always positive. So this is equal to 35 megapascal. So you have to construct 3D Mohr circle to do this. Okay. It's much quicker. If you don't do 3D Mohr circle, then yeah, I mean, you can calculate, it'll take you too long a time. Okay, so it's so much easier using 3D Mohr circle for this example. Okay, right. So let's look at example number 2. Example number 2 is one of the most difficult problem that you can see in 2D 3D Mohr circle. Okay, so let's start with this example. So for this example, we have an element, a 3D element. So this is X, Y, and Z. And on this 3D element, you have the corresponding stress state. Okay, so you have minus 70. And then you have 40 megapascal over here. You have stress Y. Okay. So given, so the question state, given that the maximum allowable shear stress is 75 megapascal, right? We have to determine the two possible values of sigma y. Okay, we have to. So if you look at this problem over here, right, we know that tau max is equal to 75 megapascal. Okay, so this tau max, okay, this tau max can be, which is can be on the xy plane, or yz plane, or xz plane. Right? For now, we don't know yet. Okay, we don't know yet. Right? We don't know whether is it on the xy plane, yz plane, or zx plane. Okay, depend on how we construct the Mohr circle. Okay, so basically the maximum shear stress. So the three circles that we have to draw, the maximum radius is 75 megapascal. Okay. Now another important thing to take note, right? So by looking at the stresses, we know that stress X is equal to minus 70 megapascal. We know that stress Z is equal to 0 megapascal. And then we know shear XY is equal to shear YX